Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. We are going to take another look at this battery charging unit that has some USB ports. Again, for the traffic light project, I looked at this in previous videos, and we are going to do some more testing with it, because the testing I did on the last one gave me an epic fail. So as you can see, I have the electronic load. I haven't hooked up the app yet, or the software yet. I have my meter. Let's turn the meter on so we can display voltage. And I have my voltage, and I have my power supply set for 2.8 volts, but I am going to put it up to 4.2 volts. And I have my DC electronic load set for 5 volts constant voltage, all singlet equipment. I am going to plug in the board to the power supply, and I am going to plug my USB port from the unit here. I'm going to plug that into the electronic load through some jumpers here. So I'm going to go to my electronic load here, and I'm going to put my jumpers. Then I'm going to plug these jumpers into my meter here, and then I'm going to plug the output of this into that. Actually, I'm going to plug this directly into the electronic load. So now I have this plugged into the electronic load here. So as you can see, that's the electronic load. I have it. I'm going to be measuring the voltage with my meter that's in the top corner, and you can see the power supply is set for 4.2 volts. I am going to turn on the electronic. I'm going to turn on the power supply, and I'm getting 4.5 volts. I'm going to hit the button. So I have 5 volts on the thing, and I'm going to turn my electronic load on. It's going to draw about 112 milliamps. So now, as you can see, I have 5 volts on the output. Now, I was curious to see if this cut off at a certain voltage, and when I just tested the voltage and lowered down the power supply, it wasn't cutting off. But now that I am drawing a load from the electronic load, why I didn't do this in the first place, I don't know. Didn't think of it. I should have thought of it. So now we're going to slowly turn this down. So we're still getting 5 volts. So we're at 4 volts. So this would be simulating a 4 volt battery. A 3.9 volt battery, we still have 5 volts. 3.8 volt battery. The battery voltage is dropping. And we're going to slowly lower it some more. So now we should be getting to the range where we want the unit to shut off. So about 2.8 is where we're looking for the voltage to drop. Now 2.9, it doesn't do anything, but if I drop it down to 2.8, as you can see, the voltage is dropping. So the voltage it's shutting itself off. It takes a little bit. It's a slow shut off, but as you can see, the unit is actually shutting off very slowly. Before, I was getting bleed out and reading the actual battery voltage, which is weird. As you can see, we are drawing no amperage from the load, and we're 220 millivolts on the electronic load. If I try to turn it on, it doesn't even turn on the output. So the unit is on. The light of the unit lit up. I'll show you that again. So the actual light lit up, it's drawing about 10 milliamps. but it is flashing with the 0% symbol, and it is shutting off. So the output is completely shut off at 2.8 volts. And now, I thought the shut-off voltage should be 3.2, but that was my mistake. I didn't think that through with lithium cells. So about 2.8 is where you want to shut it off. So adding a battery pack to this would work. You could just add an unprotected cell to this. A protected cell would be better. An unprotected cell to this will charge it, and this will also protect it from over discharge. And it does protect it from, it does do charging protection too. It actually varies the current flow. When I had it hooked to the 1000 milliamp hour cell earlier, doing some testing, which is no way this is 1000 milliamp hour. It was drawing about 1.4 amps, and then it slowly dropped down to 200 milliamps until it just shut off completely and stopped drawing current altogether. So this little MOSFET down here, is definitely clamping off the voltage and clamping off the output. It also clamps off the input when the battery voltage, I believe it was 4.2, was when it stopped putting in a charge. So at about 4.2 volts, 4.3 volts, it stopped taking current. Now I am going to run that test again with a battery, and I am going to find, it's 4.3 volts. I'm not going to get into the test again. I don't want to cycle this 1000 milliamp hour cell to death. I plan on using this in a project. I have more, but that one is mainly for testing. But this is proof that this works. The only thing is, I don't know if it'll still do this, but if I double click this, it will turn on that LED. So let's just wait a minute. It's hard to tell. Let's turn the exposure down. You can see that LED is on. It is drawing power from the power supply. The resolution on my power supply, it's saying 0.01, so 10 milliwatts. So it's not even reading current. I only have 10 milliamp resolution. I don't have the 1 milliamp resolution. This is the one that is on loan to me. So it is going to be drawing some current. I could do some test current on that, but it will run the light. So in my project, I am going to just remove this LED. I'm not even going to leave that LED in there. If I take it out of the holder and I show you the back here, and I press and hold it, you can see that it's saying 0% and flashing. Then it will just shut off. Let's see, what is that draw here? So about 10 milliamps of current when it's powered, when it's just powered off, when it's just powering on. So I am going to put it through a more sensitive meter. I'm going to run it through the Siglet 3045 meter and see what the quiescent current of the circuit is, just to see what it draws. And then I will update you in another installment of the traffic light segment. This is just an annex that's going to go out with the video before this, that's talking about this as a power supply for using your unit, and it's going to have little USB powered Arduinos that clip into each one. Each one's going to control a section of the diorama traffic light system. Looking to get some Beetles. They have more inputs and outputs. Currently I have AT Tiny 85s, that only have 4 inputs and outputs and 1 PWM. So they're just going to clip in there, and I'm going to have a... Is that LED on? No, it's not. I'm just going to have very simple, very basic. You could just throw this in a housing, run your wires, and you're good to go. But that's going to do it for this. Test equipment on the bench is this singlet gear here. I recommend it. It's fantastic equipment. I'm learning more and more stuff I can do with it. Looking forward to using the arbitrary waveform generator. I haven't got to do a video on that yet, but I will soon. Check me out on these social media links. You can also support me on Patreon, and there's also a GoFundMe page to help me set up for more equipment and to do some electronic diagnosis and repair. Thank you so much, and have a fantastic day.